How geology maps influence groundwater potential mapping. What if the secret to clean, reliable water was already written beneath our feet, hidden in rocks, soils, and ancient earth stories? Every day, millions of people depend on groundwater for drinking, farming, industries, and daily life. Yet in many places, boreholes fail, wells dry up, and water scarcity keeps growing. Why does one area produce plenty of water while another, just a few kilometers away, produces none? The answer often lies in something many people overlook: geology maps. Geology maps may look like colorful drawings of rocks and lines, but they're actually powerful decision-making tools. They tell the story of what lies beneath the surface, the rocks, fractures, soils, and structures that control how groundwater is stored and how it moves. When used correctly, geology maps can save money, prevent failed boreholes, and protect communities from water shortages. Let's break it down in a simple way. Imagine the ground beneath you like a giant sponge. Some parts of the sponge soak up water easily, while other parts are hard and dry. Geology maps show us where the soft, water-friendly zones are and where the hard, water-blocking zones exist. Not all rocks are created equal. Some rocks store water very well, while others hardly store any at all. For example, sandstones and fractured rocks often allow water to move and collect easily. Clay-rich or compact rocks tend to block water movement. Without geology maps, drilling for groundwater is like closing your eyes and guessing where to dig. With geology maps, drilling becomes smart, targeted, and efficient. This is where groundwater potential mapping comes in. Groundwater potential maps use geology maps alongside GIS, satellite data, remote sensing, and spatial analysis to identify areas with high, moderate, or low chances of finding water. Geology provides the foundation, literally upon which all other factors are built. Geology maps help answer critical questions such as, where can groundwater be stored? How deep is the water likely to be? Which areas recharge groundwater faster after rainfall? Where is drilling likely to fail? Why does this matter in real life? Agriculture farmers rely on groundwater for irrigation. Using geology-informed groundwater maps helps farmers drill productive wells, reduce water loss, and grow more food sustainably. Communities and cities, urban planners use geology maps to guide water supply projects. This prevents wasting public funds on failed boreholes and ensures reliable water for growing populations. Safe drinking water geology influences not only how much water is available, but also water quality. Some rocks naturally filter water, while others may introduce contaminants. Understanding geology helps protect public health. Climate change adaptation. As rainfall becomes unpredictable, groundwater becomes even more important. Geology maps help identify resilient groundwater zones that can support communities during droughts. Cost savings. Drilling boreholes is expensive. Geology-guided groundwater mapping dramatically reduces failed drilling attempts, saving governments, NGOs, and individuals millions. What makes geology maps even more powerful today is how they are combined with modern geospatial technology. Using GIS and remote sensing, experts overlay geology maps with slope, soil, rainfall, land use, drainage, and lineament data. This creates a clearer, more reliable picture of groundwater potential than geology alone could provide. Think of it like assembling a puzzle. Geology is the base piece. Without it, the puzzle never makes sense. Behind the scenes, geospatial intelligence transforms these maps into tools for action, helping decision-makers plan water projects, prioritize high-potential zones, and manage groundwater sustainably. At 𝐈𝐧𝐿𝐴𝐻 Geospatial Solutions, this is exactly the kind of work we believe in, turning complex geology and spatial data into clear insights. Supporting smarter groundwater exploration, helping communities, planners, and organizations make better water decisions. Groundwater is invisible, but the science guiding it doesn't have to be complicated. When geology maps are understood and used correctly, they become maps of hope, guiding us to sustainable water solutions in a changing world. If you've ever wondered why some wells succeed and others fail, or how science can reduce water scarcity, geology maps are a big part of the answer. Like this post if you found it useful. Support 𝐈𝐧𝐿𝐴𝐻 Geospatial Solutions by sharing this post for geospatial intelligence. Follow the page for more simple, powerful insights on geology, GIS, and groundwater. Do you agree that geology maps are the backbone of successful groundwater potential mapping? Type agree if you agree. Interesting. If this caught your attention, or drop a like to show your support.